Hi, welcome back. I'm welcoming you all to this beautiful online learning platform, Unacademy. We are happy to announce that we started the online training for the students who are going to appearing for GATE and engineering service examinations. Now, these classes are going to be taken care by India's top educators. India's top educators are handling the classes here. About myself, I G Venkata. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for GATE examination. At present, I am pursuing PhD from JNTU Kakinada, and my specialization is VLSI design. Now, first we check how to get Unacademy learning app into your device. Just go to Play Store, type Unacademy. You get the Unacademy learning app like this. Just click on this install button. It will install the Unacademy learning app into your device. Here are the few of the top educators from Unacademy. Tiwari sir, he is the IIT topper. Because of that, we are calling it as a top educator. And Ankit Goyal sir, he got 2 times All India first rank in GATE Electrical Engineering. And he was awarded President of India Gold Medal in IIT Indore. Sanchit Jain sir, he is having a vast experience of more than 8 years of experience and very sound experience in teaching the students. Jaspal Singh sir, ex-IAS officer, he is the All India 4th rank he got. So because of that, we are claiming that top educators are going to handling your subjects. Here are a few more top educators. Now we are going to conducting a online test series for different departments, for mechanical, electrical, civil, electronics and communication and general studies. These are the dates mentioned here, and this test series is going to be prepared by top best educators, and you are taking the test online. You will provide online ranking to you all India wise. Okay, and it is designed as per the changing demand for GATE engineering service, and 10 questions are there, 20 minutes of duration. And to unlock it, use my code VRAO10. Okay, to unlock this, use my code VRAO10 and write the exam. Next, so there is a full length mock test also is there for mechanical engineering, for mechanical and electrical engineering, civil engineering and electronics and communication engineering. Electrical engineering, mechanical, civil and electronics and communication engineering, 150 questions and 180 minutes of time. Okay, so all India ranking is provided to you if you take the test by online. Don't forget to use my code VRAO10 to unlock the text. Now, this is a golden opportunity for civil engineering students. So with Jaspal Singh sir, crack your engineering service exam with Jaspal Singh sir. So these are the different topics. Now the topic is going to be discussed on these respective dates. Okay. So use this golden opportunity. Now there is ultimate 10 SSC series for mechanical, 10 questions and 20 minutes of time. Okay, now these dates is 1st March, 4th March, 9th March, 12th and 17th for mechanical. Similarly for electrical engineering, 10th, 2nd March, 5th March, 10th March, 15th March and 18th March. Timings are 10 a.m. Similarly for civil engineering, there is a 10 minutes of time, 20 questions. 10 questions, 20 minutes. 3rd March, 18th March, 8th March, 11th, 16th and 19th of March. Timings are 10 a.m. Okay. Next, so kickstart your GATE 2022 preparation. There is a 10 questions, 20 minutes of time for mechanical engineering, electrical engineering, computer science and IT departments, civil engineering, electronics and communication, and chemical engineering. It is a test is on every Tuesday, Thursday, and Saturday at 10 a.m. At 10 a.m. Okay, to unlock, use my code VRAO10. We are happy to announce that recently we started two new batches. One for GATE 2022, other one is GATE for GATE 2023. The faculty who are handling the GATE 2023, the same faculty are handling the subjects for GATE 2022 also. Okay, now this is for mechanical engineering. This batch started from 22nd February 2021. Next, there is a Evolve batch for GATE 2022, same mechanical engineering. The same team who are handling the GATE 2023, the same team. It was started from 22nd February 2022. Next, there is a Spark batch for GATE 2022. This is only English batch, and this is for civil engineering students. It started from 22nd February 2021. Next, there is a Mission DDR. This is for mechanical engineering students. This is for mechanical engineering students. Okay, now we started this batch with the intention that every student can get good rank, top rank. With that intention, we started this batch. Here are the top educators who are working under this: Tiwari sir, Umeshwaram sir, Menu Gupta ma'am, and Aman Raj sir. This batch started from 22nd February. Next, we move to civil engineering. There is a SN batch for GATE 2023. It was started from 8th February 2021. And Evolve batch for GATE 2022. This batch started from 8th February 2021 itself. And there is a Evolve batch for GATE 2022 for computer science and information technology. Here are the top faculty who are working under this: Ravindra Babu sir, Sanchit Jain sir, Subbara sir, Mallesham sir, Vishwadeep sir, and Shweta Kumari ma'am. Here are the top educators who are working under this batch. This batch started from 8th February 2021. Next, move to electrical engineering. There is a Ascent batch for GATE 2023, and this batch started from 1st February 2021. Here are the top faculty who are working under this. Next, we move to electronics and communication engineering for GATE 2023. The same faculty who are working under this GATE 2023 are also going to handling the classes of GATE 2022. This batch started from 1st February 2021. Next, there is a Evolve batch for GATE 2022 electrical engineering. The same batch who are handling the GATE 2023, same batch are handling GATE 2022. This batch started from 1st February 2021. Next, there is a Evolve batch for GATE 2022 electronics and communication engineering. The same batch who are handling the 2023 classes, the same batch is handling this, and this batch started from 1st February 2021. This is for chemical engineering. There is a Evolve batch for GATE 2022, and this batch started from 25th January 2021. Now, just we glance at different departments what we are available from Unacademy: ECE, chemical engineering, mechanical engineering, computer science and IT departments, instrumentation engineering, electrical engineering, civil engineering, production and industrial engineering. Okay, these are the different engineering disciplines available. Next, there are two basic plans available here. First one is a plus plan, next one is iconic plan. Plus plan is the basic plan. Iconic plan, in this iconic plan we will take your preparation to the next level by providing a personal coach to you. By providing a personal coach, we will take your preparation to the next level. In both the cases, India's top educators are going to handling your subjects. There are interactive live classes are there. structured courses and PDFs, live tests and quizzes are there. Now here we are going to show the difference. Here we show the difference, and at the same time, whoever the personal coach we allotted to you, he is going to analyze the exam paper what you've written. Okay, he will analyze your exam paper completely, and he take a note on where you are strong, where you need preparation, where you are doing mistakes, okay, where you are lagging. He prepare a note like that, and based on all these things they prepare a proper study planner to you, and they prepare respective study material also to you. By providing these two to a student, and by following these two, every student gets success in their examinations. Now we move to plus plan. In plus plan there are different subscriptions are there. Now for every subscription there is a EMI plan also is available, equal monthly installments. 1 month subscription, 3 month subscription, 6 months, 1 year, 1.5 year and 2 year subscriptions. Okay, now as a faculty I recommend the students to take minimum of 1 year subscription. For a student, this 1 year is required to understand all the topics, to understand all the subjects in our syllabus effectively, and to revise the subjects multiple times, and to write more number of examinations, to identify the gap in their preparation, and to fulfill those gaps. For every student, minimum of 1 year is required. That's why I am recommending the students to take minimum of 1 year subscription. Minimum of 1 year subscription. The cost of this one is 30,250 rupees. 1 year subscription. Okay, by using my code during subscription VRAW10, its cost is 27,225 rupees only. And the cost what you observed here is going to be more or less just by adding a little bit amount to the transport charge. Means if you joined it outside to take a training during weekends and public holidays, you have to be attend worst case, and throughout the year that too. So for that throughout the year transportation, its cost is more than 20,000. Just by adding a little bit amount to that, you can get the benefits more than that. Your classes are handled by India's top educators and well experienced faculty. Okay, and online classes are there. No need to move anywhere from your home. Now that means you are in safe position. And every day for transport you need to spend nearly 2.5 to 3 hours of time. Now you are going to saving that time. Okay, so by staying at your home itself, you can save the time and you can spend that time for your preparation. Okay, these are the benefits. Once think of it and take a right decision. Now we move to Iconic plan. In Iconic plan, there are two subscriptions. There is a 1 year subscription and a 2 year subscription. For 1 year subscription, its cost is 50,250 rupees, and for 2 year subscription it is 74,000. For 12 months of 1 year subscription, by using my code VRAW10 during subscription, you get it by 45,225 rupees only. 45,225 rupees only. Okay, that means this amount is more or less the amount what you are paying to the outside institutions for offline training. Here you are getting offline training with this amount, but you are going to getting more benefits than that. Especially we are providing a personal coach to you. Okay, he behaves like a mentor, guide. Okay, your examinations is going to be analyzed. They will prepare proper material whatever you want. what not, everything they will take care of your academics. Okay, with that intention we started this. So my dear students, please think once of it, discuss with your friends, family members, the faculty who are having the knowledge on GATE and engineering service examinations, and take a right decision. Okay, now thanks for spending your time. Now we are moving to our topic, JFET, Junction Field Effect Transistor. Junction Field Effect Transistor. Okay. Now, JFET, Junction Field Effect Transistor. It means first I am going to defining what is transistor. Here already we defined. It is basically a current device. It can be controlled by either input current or input voltage. If you control this by using input current, it is called current control current device. If you control it by input voltage, we call it voltage controlled current device. Okay, now voltage controlled voltage device also is there, that is op amp, operational amplifier. Now just I am glancing the things, sir. Field effect, FET. FET means field effect transistor. Just before we define what is transistor. Now the working principle of this one is field effect. This is the working principle of this. Now, what is field effect? It is the process of modulation of longitudinal current flow between two terminals of the device by a transverse electric field applied to the third terminal. These are the, so let us take this material. In this, current is flowing between these two terminals. Now current between these two terminals is controlled, or modulation of that current means controlling. Okay, changing by applying a transverse electric field. Transverse means perpendicular electric field on this. We are applying that electric field by applying a voltage. Okay, now this is the overall representation of a FET. A FET can be the basic terminals in this is a source, gate and drain. Now flow of carriers from source to drain is controlled by gate. So gate is going to controlling the flow of carriers from source to drain. Now gate is not providing, tap is not providing even single charge carrier. Because of that, always gate current is 0 and source current equals to drain current. Okay, now so these are the, now how we are going to be realizing that field effect principle. Okay, where we are applying the technique. Based on that, we classify this into different types: JFET, MESFET and MISFET. JFET, junction field effect transistor. MESFET, metal semiconductor field effect transistor. MISFET, metal insulator field effect transistor. And this is also called as MOSFET and IGFET, insulated gate field effect transistor. Okay, these are the different types. Next, FET. FET is a unipolar device basically. In this, current is due to majority charge carriers. Here less temperature dependent, and it is more immune to radiation. Because of this more immune to radiation only, it is used in satellites as an amplifier. And fabrication of FET is simple compared to BJT. Less number of steps are sufficient and they occupy less area on the chip. Now these are the JFET. How we are going to applying the field effect. Okay, field effect is obtained by applying a voltage across PN junction. Here field effect is obtained by applying a voltage across metal semiconductor rectifying contact. And in MOSFET, field effect is obtained by applying a voltage across metal insulator semiconductor interface. Next, there are two types of JFETs, N-channel JFET and P-channel JFET. Now, in N-channel JFET, current is due to electrons. In P-channel JFET, current is due to holes. Now, this is the construction of the JFET, N-channel JFET. See this? First, we take a lightly doped N-type semiconducting bar. We are taking this one. This is a lightly doped N-type semiconducting bar. So lightly doped N-type semiconducting bar it is. Just a minute. Yeah, lightly doped N-type semiconducting bar it is. In this, to opposite side it is doped heavily with p-type impurities. Now it is p plus. Now it is lightly doped N-type semiconductor, it is p plus. Now there is a junction between these two and depletion region takes place between these two. Now the depletion region is extended more towards lightly doped region at the junction. We know that. Now the region is called, between these two p plus regions, is called channel. And this is the length of the channel L. And this is the cross sectional, and this is called Z, let us. Okay. Now next diagram I will show it. See, during the operation of JFET, a voltage is applied at gate and drain terminals with respect to source terminal. Now the voltage at VGS applied at gate, VGS, is called gate to source voltage, and the VGS is applied such that the gate current IG should be 0. Okay, in that view we are applying the VGS. Our intention to apply VGS is just to make IG equal to 0, such that you need to apply the VGS. Sorry. And VDS, drain to source voltage. Next. So this is your FET, two-dimensional representation of your FET is like this. This is the two-dimensional representation of your FET. Okay, in this is the channel, lightly doped N-type semiconductor, source and drain. These are the gate terminals. Here is your gate, and these two gates are going to be shorted. This is the gate terminal. Both are shorted. Now we are going to the a little bit analysis here. Okay. Now, okay, later we go to that analysis. Now, first I am going to the operation of this. See this? Now we are moving to the operation of this. See this? This is our JFET. In this is lightly doped N-type semiconductor. Now the region which is common to between these two is called the channel. Now during operation, first I am going to keeping VGS constant and changing the VDS value. Or we do one thing. First we are going to keep VDS constant, and after that we are going to vary the VGS, because here I want to define few things. Because of that parameters I am going like this. Now operation. So first what I am doing is keeping VDS constant, and varying VGS. VGS. Varying VGS. Now what happens? By doing this, what happens? So this is our FET. For drawing the diagrams, it takes time. Don't feel bored. Parallelly take a note. I'm not going to drawing any terminals, any more terminals, because our intention is to concentrate on channel, how channel is varying. That is my intention. Now see this, it is P plus heavily doped. It is lightly doped n-type semiconductor. And okay, for this we take the channels. So I'm going to copying this up for future reference. We need this diagram. I'm going to copying this. Now this is the source, drain and gate. This is the most important thing, is channel. Most important thing is channel. Now we are going to applying a voltage, a constant voltage. VDS is constant, you are saying, and varying the VGS. Okay, so once you connect a constant voltage between drain to source VDS, this is VDS, a constant voltage between drain to source. Once VDS is like this, now drain is positive, source is negative. Once drain is positive, source is negative, electrons are going to be moving like this. Electrons are moving like this. This is the movement of electrons. Now electrons are moving like this, and automatically in opposite direction current is flowing. This is the direction of the current. That is ID, drain current we called it. And here it is source current. The drain current equals to source current. The number of electrons leaving from source are reaching the drain. Okay, that means the amount of current coming out of the drain is reach the source. Because of that only we taken ID is equals to IS equals to ID. Now one very important point here is how we are going to operating VGS. That is very important thing. Okay, sometimes they will ask the polarities of this VDS and VGS also. Okay, now first what I am doing is, in step 1, in this operation I am taking this step 1. In step 1 I am taking VGS equals to 0. VGS is equals to 0. So VGS equals to 0 means both gate and source are shorted. Once both gate and source are shorted, the full channel is available for conduction. Once VGS is 0, full channel is available for conduction. Therefore, for VGS 0, full channel is available for conduction. Channel is available for conduction. So once full channel is available for conduction, we get the more current. So ID is maximum. Therefore ID is maximum. Now that ID maximum is at VGS 0. ID is maximum at VGS equals to 0. Okay, at VGS equals to 0. And I am calling that ID maximum is, I am calling by IDSS. IDSS. IDSS is the maximum drain current flowing through the channel. So IDSS is equals to maximum drain current. Drain current. This is the step 1. Now we are going to increasing the VGS value. And in what way we have to increase the VGS value? Positive or negative VGS we have to take. That is the important point here. That is going to decide the operation of this. Okay. Now what is the polarity of that one? VGS, positive or negative? Now I'm adding terminals to this for future reference. So this is gate terminal, drain and source. Yeah. Now this is the diagram. So just what we said, VDS is constant. So first I am going to moving the diagram. Okay, just I am keeping this one here. Fine. See, VDS is constant. Just by applying a VDS, a constant VDS I am applying. Previous case we taken VGS 0. VGS 0 previously we taken. Now I want to take a proper value of VGS. Now just we go back 1 minute. How I want to take VGS value? In which way I want to take VGS value? See this? See this? VGS, gate to source voltage. The VGS is applied such that the gate current IG equals to 0. So while applying the VGS value, you need to take care about the gate current should be 0. In that way, you need to take the VGS value. Now I am doing the same thing here. Okay. Now see this. So this is P. To get a current through this is channel. See carefully. This is channel. This is channel. Now to get a current through this, I want to get this current is gate current. I want to make this current 0. To make this current 0, it should be, this junction should be in reverse bias. Then only we get the current, our gate current is 0. It should be reverse bias, means P connected to negative. So negative, positive. This is very important, sir. Therefore VGS is this one. So VGS is negative. Therefore VGS is negative for, therefore VGS is negative and VDS is positive for N channel transistor. N channel JFET. JFET. Similarly, VGS is positive and VDS is negative for P channel JFET. P channel JFET. P channel JFET. Okay, sir. P channel JFET. These 2 points are very important. In previous GATE examination, they asked the polarities of VGS and VDS. So my dear students, please take a note of this. These 2 are very important topic points. Now I am going to VGS side. Once VGS is negative, so now, so once so VGS you are taking negative, less than 0. So once VGS is negative, what we are expecting is gate to channel junction is reverse bias. Gate to channel junction is in reverse bias. Reverse bias. Then what happens? Once gate to channel junction is in reverse bias, what happens? Now we check it. Yeah. See this? Now, when VGS is less than 0, it means negative. Less than 0, that means VGS is negative. Negative. Gate channel junction is in reverse bias. Gate to channel junction is in reverse bias. In reverse bias. Once gate to channel junction is in reverse bias, the depletion region width at gate to channel junction is increasing, and that too it extended more towards lightly doped channel region. Gate to channel junction is in reverse bias. Next. Now it results after this. Now the depletion region width between gate to channel increases, and once gate to channel depletion region width is increasing, that too it extends more towards lightly doped channel. Therefore it extends more towards lightly doped channel region. It means depletion region. Depletion region. A minute, I will copy that diagram. We need this diagram. Now say this. See? When VGS is less than 0, that means VGS is negative. This gate to channel junction is in reverse bias. When it is reverse bias, the depletion region width between this junction, because this channel is lightly doped n-type semiconductor. This is lightly doped n-type semiconductor. Okay. Now this gate to channel junction became reverse bias, and the depletion width between gate to channel increases, and that means the depletion region extends more towards lightly doped channel region. That means this is extending towards this. That means now the depletion region is like this. This is the depletion region. It is extending more towards lightly doped region, you are saying. It is extending like this. Like this. Now the available channel is going to be decreasing. Previous case, this is the first case channel. This is the amount of channel available in first case. Now this is the channel available. This is the second case channel available. This is the channel available when VGS equals to 0. This is the channel when VGS equals to 0. This is the case when VGS equals to 0. This is the case when VGS is less than 0. Therefore, the amount of channel is decreasing. Therefore, the amount of channel is decreasing. Amount of channel is decreasing. So once channel is decreasing, initially this much current available, now channel is decreasing. Channel decreasing in the sense channel resistance is increasing. It means channel resistance is increasing. Resistance is increasing. Here channel resistance means that is RDS. Channel resistance is RDS. Drain through source resistance. Channel resistance is RDS. Drain to source resistance. So channel resistance is increasing. So once RDS is increasing, now our equation for ID is VDS by RDS. So you are saying it is constant. It is constant. Now this is increasing. Once RDS is increasing, ID has to be decreased. Therefore, ID decreasing is decreasing. Decreasing. Okay. Now, continuously I am going to increasing the VGS value like this. See this? Now, by increasing that means VGS continuously, VGS that means negative value. I am going to increasing the negative value of VGS continuously. See, the amount of channel is going to decrease continuously. The amount of channel also going to decrease. So going to decrease. At one particular value of VGS, value of VGS, the channel is closed. The channel is closed. That means, see this here, this is VGS less than 0. Now increasing the VGS value, increasing the VGS value in a negative direction. Now this is going to be increasing like this. Now your channel also going to be increasing like this. Like this. Depletion region width is increasing. Now the available channel is decreasing. Like this it is. Now only this is the available channel. In this case, This is the net available channel in third case. Let us take this is step 3. This is step 3. Now this is the step 3 channel. Channel is decreasing, goes on. Okay, that's why RDS is increasing, ID is decreasing. Now at one particular value of VGS, the channel is closed. Channel is closed in this sense, pinched off, pinch off. That means, what is the meaning of that? I will show you in next diagram. Now, here this is the gate terminal. See, you are saying channel is closed. Channel is closed. So channel is closed in this sense. Your channel is going to be completely filled by, see, channel is pinched off. It's pinched off. That means closed. That means your plot, it is like this. No channel, no more channel. It is filled by complete depletion region. Filled by complete depletion region, like this. Okay, so therefore no more channel. No more channel. So once no more channel, therefore ID is 0. Now the value of VGS at which channel gets pinch off. This is called pinch off. Channel gets pinch off is called pinch off voltage. Therefore, the value of VGS at which the channel is pinched off is called pinch off voltage. Pinch off voltage. The value of VGS at which your channel is closed is called pinch off voltage. Now, see, therefore, VGS at a condition of channel pinch off, channel closed, is called pinch off voltage. VP, pinch off voltage. Channel closed in this sense, no channel. No channel. That means it can also represent another way. A VGS value at ID equals to 0. That means ID value 0, there is no more current, equals to pinch off voltage. Okay, like this it can be defined in different ways. Now I am going to representing whatever the things or whatever the points so far we studied, all those things I am going to be placing on a plot. See this. So this is the plot. Here This is ID and this is VGS, negative value. Okay, at VGS equals to 0, we know that ID is maximum. So step 1 is at VGS equals to 0, ID is maximum. Now therefore ID maximum, we are representing it as IDSS. Maximum ID we are representing as IDSS. So this is the, at ID equals to 0, VGS equals to 0, ID is maximum. Let us take this point is IDSS. Maximum drain current. The second one, by decreasing VGS, that means by taking VGS, by increasing VGS in a negative direction, by increasing VGS value negative, that means increasing the VGS in negative direction, ID going to decrease, ID is decreasing. So this value is going to decreasing here, ID value is going to decreasing here. Okay, now ID is decreasing. Now third point is at VGS is equals to VP, pinch of voltage, ID became 0. Now let us take this is minus VP, pinch of voltage. At this point ID became 0. Now the plot is like this. A parabolic way it is going to be changed like this. So this is the plot. Okay, this is the plot between ID versus VGS, and we also called it as transfer characteristics or transconductance characteristics. Okay, there is no input characteristics for FET. Why? Because whatever the value of VGS you can apply, always gate current is 0. Because of that, there is no input characteristics for FET. Okay, JFET. So next class we continue from this point. Okay, and thanks for your patience, and don't forget to use my code VIRA10 during subscription. Please hit the bell icon for getting notifications and subscribe us. Please give your valuable comments on YouTube and join our Telegram group for getting latest updates on our upcoming videos. Okay, now once again I am welcoming you all to this beautiful online learning platform, Unacademy. Okay, thank you very much.